Dear children, I am here again with physics with the continuation of chapter number 2, that is measurement of area. Okay, so in the last session we had a talk about the measurement of temperature, where we discuss about the definition of temperature, the devices to measure the temperature, that all we discussed. I hope you all have understood it. Now we are in the next portion of this chapter called measurement of area. Okay, first of all we need to know what actually area is. Okay, what do you mean by area? So area is the amount of surface occupied by an object. Okay, the amount of surface is not space. Okay, this surface and space, sometimes you get confused with these words. Okay, surface and space. So space means the other word that we can say to this, regard this surface, space to be the volume where we consider the length, breadth and height of that object. Okay, that is volume. But here we are not talking about volume, we are talking about area. So where we consider only length and breadth of the object. So that length and breadth when we measure, so that will be the amount of surface of that object, which is called area. In simple word or in a simple sentence, it is defined as the amount of surface occupied by an object, that is the area. See here now, here I have drawn the different figures as I have taken from your book itself. So okay, it is there in the book. So I have considered three different kinds of objects having these shapes. See here, so this is the object having this shape, triangular shape. Another object in the square shape, the another object you see in the triangular, in the rectangular shape. So what is the area of each of these objects drawn on the board? The area of each of these objects drawn on the board is the colored part, the colored portion occupied by this object here is the area. And in the same way, enclosed within this object, within this figure, whichever the colored portion you see here, enclosed by this figure is your area. Similarly here also. Okay, and to measure the area of each of these types of figures or each of these types of objects having this kind of figures, this kind of shapes, there is formula. Okay, for example here, this is the object of this shape called triangular shape. So formula is usually this one, half into b into h. Okay, half. What is half? So here the imaginary line is taken here. That is will be height, base, and your half. That formula will be applied, which is not applicable to you in this standard. Similarly here, this is square. Square means all sides equal. All sides equal. So if it is 5 centimeter, so all other sides also 5 centimeter. So to calculate the area of this object will be side square. Here is the formula called side square. And here the figure is in the rectangular shape of the object, or the object in this shape, rectangular shape. To measure the area of this object, we take length and breadth. Formula is length into breadth. That is there. But these two can be done at this standard itself, but this one to find the area of the triangular object. Okay, then similarly circle. Okay, so this will be done in your higher class itself. So here what we have to understand is that the area of the object. Area means the amount of surface occupied by an object, which is usually measured by taking the length and breadth. Okay, length and breadth. When we calculate the length and breadth, length will calculate how much it is, will be multiplied by the breadth. So that way we can calculate the area of the regular object. These are the regular objects. But in some cases, the shape is not regular, where we cannot take length and breadth. So there some other methods are there that we'll discuss. Okay, that we'll discuss afterwards. Now we'll see SI unit of area. what is the unit we use here in the measurement of area. The SI unit of area is square meter, or it is the square meter. Okay, square meter. The international system of unit or SI unit of area is square meter. Please remember, it is square meter. So why it is square meter? Because here length and breadth is considered. Length and breadth, you see, length and breadth are measured and will be multiplied. So for example, let's see here, just I will take the example for this. Here, this one. See, suppose this is your school ground. Okay, it is a school's ground which is in the rectangular shape. Let's say here it is length is your 50 meter. Okay, the breadth is, suppose, let us say 20 meter. Now, what is the area of your school's ground? To measure that, what you do is that you will follow this formula, length and breadth. Length, as I've taken, is 50 meter and breadth is taken as 20 meter. Multiply it. 20, 50, 20 is how much? 2 zeros are 0, 2 5s are 10. So 0, 0, 0. That means 1000. 1000. M into M means M square meter. So your school's grounds area is how much? 1000 square meter. So this square meter is used out here. Okay, that is the SI unit of area. Sometimes we need to find the area of the very small object also. In that case, we can use smaller units like square millimeter. What is that here? Square millimeter. Square millimeter can be used. Square millimeter. If otherwise, we can use even square centimeter. Okay, so that we can use there. Suppose the area of this paper is to be measured. So we measure this side, length and breadth. So in centimeter, centimeter, let us say this side is suppose 20 centimeter. Okay, let's say here it is here. Let's say it is here 20 centimeter. The other side, let us say it is 10 centimeter. Calculate 20 centimeter into 10 centimeter will be how much? How much? We can calculate. If you know this one, you see, for your convenience, I'll just multiply here. You just have to multiply here. Okay, so it is 200 cm into cm is cm square. That is the area of your paper. Okay, so a smaller unit has been used out here, where you don't use the meter, because meter is bigger unit than the centimeter and millimeter, so that here that we cannot use. Okay, so and if the area of the country, if the area of a city suppose has to be measured, so there this meter only is not enough, so that is too small, so there we can use the bigger unit. Okay, we can use what? Bigger unit. So that way we can measure the area of the object, or the the ground, or your village, or your city, or your country. So accordingly we use the multiple and sub multiple units. Okay, so for that here in the book some relation is given here. You can see measures of area. I'll just rub the both here once again. Suppose here it is given measures of area 100 millimeter square 1 centimeter square, or square centimeter. So 100 square millimeter equal 1 centimeter. That means 100 square millimeter make 1 square centimeter. That's the relation. It is given up to the kilometer. So all I cannot write. You can just see this. You can copy it in your copy and also learn this. So I can tell you how it is. I have already discussed there in the class also the relation. Okay, I have already written. Suppose it is like this. Now 10 millimeter make 1 centimeter. Okay, 10 millimeter make 1 centimeter. So here you have to convert it here. This centimeter, square centimeter has to be converted into the millimeter. So how you do it? So how you find 100 square millimeter equal 1 square centimeter? To tell you, see here. So here, how many cm is there? How many cm? 2 cm. That means how many centimeters? Okay, 2 centimeters. 1 centimeter into other centimeter. See here, cm square means cm into cm, centimeter into centimeter. So centimeter into centimeter, then only it makes how much? How much it is? Cm square. So here 1 cm equals 10 millimeter. 1 cm equal, see here, 1 cm equal 10 millimeter. Means it is 1 cm only here. 1 cm into 1 cm is how much? 1 ones are 1. How much? 1 ones are 1. So 1 ones are 1. Cm square, cm into cm square. So 1 cm means 10 millimeter into 1 cm into another 10 millimeter. So multiply it. 10 tens are 100. M into m, mm into mm square. So here cm square. So here see, this is how it is calculated. Okay, in the same way, so other also can be measured. Okay. Okay, now we'll do the measuring the area using graph paper. Okay, so graph paper, you must have seen graph paper. So here, see, if you see a science copy, then you see the paper like this, which is called graph paper. Okay, so using this graph paper also, we can measure the area of number of objects. Like you see the area of your hand, okay, the area of your some irregular objects, like you see the leaf. Okay, so there we can use to measure the area of such objects on the graph paper or using graph paper. So now how do we use graph paper to measure the area? Let us see now. The method is given there in the book also. You see the graph paper here. So the graph paper contains a number of boxes here. Okay, each box has the area of 1 centimeter square. That means 1 square centimeter. Each box. Okay, so each box is 1 square centimeter. The area of each box is how much? 1 square centimeter, which means the length is each side is what? 1 centimeter, 1 centimeter, 1 centimeter, 1 centimeter. Each side of each box measures 1 centimeter each. So the area will be side square. That formula will be applied. Side square means 1 cm square. 1 cm square means 1 cm into 1 cm. So 1 ones are 1, cm into cm is cm square. So that means each box of the graph paper has the area of 1 square centimeter. Okay, so that's what you find here in the graph paper. That means each box of the graph paper contains the area of 1 square centimeter. So now, suppose you are going to measure your hand, the area of your hand. What you do is that, or anything like paper or your what do you call it, see your leaf, this kind of leaf, which is having the irregular shape here. You cannot take the length or breadth of this paper, of this leaf. So there you can use, okay, that means that graph paper can be used in measuring the area of this object here. Okay, so like that, you'll have to trace it here. You'll have to trace it here like this. Okay, and with the help of pencil, you'll have to take the outline of this, of this leaf. Then after that, there is a method. So here, using the same method here, I am going to take the area. I am going to measure the area of my hand. Alright, let's see now how we are going about. So this is the graph paper you have already taken. Keep it there on the table and just keep your hand on that graph paper. Okay, then you want to do, take the outline of this your finger or of your hand on this graph paper like that. Now remove it. So you have already drawn the outline of your hand. Okay, so now you have to measure the area of the outline of your hand using this graph paper. Okay, so now see area. So how you have to measure the area now. So for that, what to do is that first you need to count the complete squares, a complete number of complete boxes, number of complete boxes enclosed by the outline of your hand. Okay, number of complete boxes plus number of incomplete boxes divided by 2. That's the method, that's the formula in fact. So number of complete boxes, count the complete boxes here first. Which are the complete boxes covered? So here I can see this one, okay, 1, 2, 2, 2, so here 3, 4, 5, 6, 7, 8, 9, 10, 11. So these are the 11, 12. So these are the complete boxes. I found 12 plus number of incomplete boxes. Some of the boxes are here which are not completely covered by the outline of your hand. Okay, count them also there now and have to write this side plus number of incomplete boxes. So how many such incomplete boxes are there now? Count it. So here is 1, 2, and those incomplete boxes which are above 50%, which are covered, which are enclosed more than 50%. Okay, some are there which are covered less than 50% or like 20%, something like that. But those incomplete boxes which are covered above than 50% only need to be counted here as half. Okay, so I've counted 1, 2, then 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so 12 boxes. 12 boxes are the which are incompletely enclosed by your outline and by 2. That 2 is there. So since it is there in the bracket, so you can directly cancel it here. 2 6 are 12. Okay, so now count it. 12 plus 6, 12 plus 6, it will be 18. So total 18 boxes approximately, not it is it is accurate, but approximately Okay, approximately there are 18 boxes covered by the outline of your hand, which means 18 boxes are there which are covered by your hand. And 18 means how much? How much area? 18 means how much area? Which means, as you have already come to know, that each box equal 1 square centimeter. That means each box has the area of 1 square centimeter. So that 18 boxes means it is 18 square centimeter. That means the area covered by the outline of your hand is how much? 18 square centimeter approximately. So this is how we can use graph paper to measure the area of such figures or such shapes where length and breadth cannot be taken. So that way we can make use of the graph paper. Okay, so this is how we can measure the area of the leaf also. Okay, then as I've told you already that there are of different figures of different shapes. Okay, as I've already told you that there is the object of which shape, that square shape also. Okay, triangular shape also, rectangular shape also, and it may be in circular shape also. So there accordingly will apply the formula there. Okay, so formula is there. So as I've told you, the to measure the area of triangular shape, we need to apply the formula of half into b into h, half into base into height. Similarly, the area of circle, if the shape is there like a circle, so there we have the formula called pi r square. Pi means 22 upon 7 into r square. R means radius. So that all need not to be done by you, because that we will do in your higher class, like in 7 or 8 onwards we'll do there, but it is not needed here. And as I've told you, some of the things also, like you see there in the book. Okay, there in the book, this kind of figures are being given, which I have already discussed. This is the rectangular shape, where we simply take the length and breadth, we'll multiply it, and we get the area. Similarly here, the shape of square is given here, where we'll measure one side and we'll multiply by the same number, twice, like side square. That formula will apply, we have already discussed. And if the area of the small object is there, we use the smaller unit like millimeter, centimeter. And if the area is to be measured of the bigger, say let us say country or city, so there those centimeters and millimeters cannot be applied. So there we use the higher unit like kilometer, square kilometer. Okay, square kilometer. So today we'll do only this much. And I just want to give you a small assignment for you, that is, choose the correct option, page number 30, and true or false, page number 31. Please do them as your homework. Alright, so today we'll do only this much. Thank you very much.